Hi students, in this session we are going to discuss about the effects of feedback amplifier. So already we know the working of operational amplifier, then the feedback. Actually the working depends upon the feedback given to the circuit. Here, before knowing about the effects of feedback amplifier, we should know the types of feedback. What are the types of feedback? Negative feedback and positive feedback. Then we will see a sample circuit for a feedback circuit. So this is the amplifier circuit. Input given to the amplifier circuit. Then we are taking output from the circuit. This is a feedback circuit. Feedback circuit with a feedback fraction beta. Then here one circuit, either it is adder or subtractor, depends upon the, if it is a negative feedback, it is a subtractor. If it is a positive feedback, if it is a adder. This is a sample diagram of a feedback circuit. We will see one by one, that is negative feedback circuit and positive feedback circuit. First, negative feedback circuit. Negative feedback circuit. What is the diagram here? Here, subtractor. This is a negative feedback circuit. That's why this is a subtractor. Then again, here is a feedback circuit. Okay. Here, operational amplifier. Then feedback we are giving. Here we take V out. This here Vs. So here the fractional value, feedback fraction value is beta. So here, so beta V naught. Okay. Normally, for a amplifier with a feedback, we know the, for inverting amplifier or non-inverting amplifier, we know the equation of the feedback. So what is the gain of the amplifier? Gain equal to V out divided by V in. This is the gain equation. Okay. Here, see here, this is a feedback circuit. This value is beta V naught of a amount of signal is given, again fed back to the input. A portion of the output is taken from the output and given back to the input. Okay, this is the formula for gain. So we know without absence of feedback, if no feedback, V in equal to Vs. Okay. Then if I'm giving a feedback, if I'm giving a feedback, that is, if I'm giving feedback, that feedback signal is fed here. So it means that the V in equal to Vs minus beta V naught. Understood? So if no feedback, V in equal to Vs. If you are giving, if you are giving feedback, so V in equal to Vs minus beta V naught. Okay, in this equation, we are substituting V in value, V out divided by Vs minus beta V naught. Okay, already we know the symbol Vs equal to V in. That's why we are using, instead of Vs, we are using V in. So, A into V in minus beta V naught, just a multiplication, equal to V naught. So here V in equal to assumption. That's why we, instead of Vs, we are using V in. Okay. That's why just a cross multiplication, A into Vs minus beta V. That's we are writing V in minus beta V naught equal to V out. So just we are multiplying A V in minus A beta V naught equal to V naught. So we are moving this term this side, it crossing the equal, that is A V in equal to V naught plus A beta V naught. So V naught is a common one we are taking out. V naught is, that is 1 plus A beta. So we know the formula, that is V out by V in is called gain. So this V in comes this side. So A by 1 plus A beta equal to V out by V in. This is the final equation of the gain equation of the negative feedback circuit. See here, negative feedback means we have to add the subtractor here. So without feedback, V in value is equal to Vs. If you are giving feedback, that value is subtracted here. That is V in equal to Vs minus beta V naught. So we know the formula for A equal to V out by V in. So instead of V in, we are substituting Vs minus beta V naught. So we already have the assumption that V in equal to Vs. That's why instead of this Vs, we are substituting V in. So just multiplying that A into V in minus beta V naught equal to V naught. After simplification, we are getting the equation like this. Okay, this is the negative feedback, gain of the negative feedback circuit. See here, in the denominator, there is a factor added here. This is a normal gain. Here we are having 1 plus A beta. Because of, so the formula is, gain formula equal to, A by 1 plus beta A. So 1 plus beta A, this formula. See the denominator. Because of this denominator, the gain value, it reduces the gain value. So the gain value is reduced here. It reduces the gain value. Because of the reduction in gain value, it also reduces the distortion value. It also reduces the noise and circuit instability. These are the effect of negative feedback. This is after giving negative feedback, we will get this gain equation like this. So it shows that reduction of gain, because of the reduction in gain, there is a reduction in distortion, noise and instability. But it increases the bandwidth and it improves the input and output impedance. Because of these advantages, so negative feedback amplifier will be used as a negative feedback circuit will be used as a amplifier circuit. This is the effect of negative feedback. This is the effect of negative feedback. It reduces the gain value, distortion value, noise and circuit instability value. It increases the bandwidth and it improves the input and output impedance value. So that's why this is used as a negative feedback circuit is used as mostly used as a amplifier circuit. Okay, a operational amplifier with negative feedback is used as a amplifier circuit. Okay, next we will move to the positive feedback. Positive feedback. What's the diagram here? Here's a adder, V in. So Vs amplifier circuit, operational amplifier circuit. We are taking V out. This is a feedback circuit with beta V naught. When no feedback, everyone know. So we assumption that V in equal to Vs. If feedback, we are applying feedback. What is the value? V in equal to Vs plus beta V naught. So we know the gain equation A, the feedback, V out by V in. So we are substituting the value V out divided by, so here Vs plus beta V naught. So already we have the assumption here. That's why this is replaced by V in. So here A. So cross multiplication A into V in plus beta V naught equal to V out. So A V in plus A beta V naught equal to V naught. So A V in equal to V out minus beta A V naught. So we are taking V naught as a common one, 1 minus beta A. So if you are simplifying the equation, so V out by V in equal to A by 1 minus beta A. What's the difference here? So in the previous one, we are getting 1 plus beta A in the negative feedback. In a positive feedback, we are getting 1 minus beta. Okay. So here, what is the effect here? Will erase. What is the effect here? The effect is, so here, this is a minus value, no. There is a minimum value. Because of the positive feedback, there is a minimum value. So hence, the effect is, effects of positive feedback is gain value is increased. Because of the increase in the gain value, automatically the distortion also increased, noise increased, the circuit instability also increased. That's why a negative feedback, a positive feedback amplifier is mostly used as a oscillator circuit. I hope you people understood. See, what are the types of feedback? Positive feedback and negative feedback. This is a general feedback circuit. Based upon the positive negative feedback, we will add the adder or subtractor. So now negative feedback, we are the subtractor. Without feedback, so V in equal to Vs. If feedback, that beta V is subtracted, we are having the derivation that gain value is A by 1 plus A beta. It means that it reduces the, it is a high value, it divides the already available gain value. That's why it reduces the gain, distortion, noise and instability of the circuit. Then it increases the bandwidth and it improves the input and output impedance. That's why that as negative feedback circuits are used as a amplifier circuit. The same way, we are positive feedback, we are getting the equation as A by 1 minus beta. Here the gain value is reduced here. Then in this topic, we should know that, that is, we should know what is that, what are the, that is analysis of, wait a minute, I will rub the book. Okay, so analysis of practical feedback amplifier. Okay, here, before going to analyze the circuit, we should know the topology. What are the topology involved in the feedback amplifier? The first one is series feedback amplifier. It means that it is otherwise called current series. It is otherwise called current series topology. Second one is shunt and shunt. This one is called voltage shunt amplifier. Next one is series shunt. This one is called voltage series amplifier. Next one is shunt series. This is called current shunt amplifier. So analysis of practical feedback amplifier involves four topologies. What are the series topology, shunt topology, series shunt topology, and shunt series topology. See, series topology otherwise called current series. Shunt topology is otherwise called voltage shunt topology, and series shunt topology otherwise called voltage series. The shunt series otherwise called current series. Okay, guys. Thank you, guys. We will meet in the next session.